So consider two bodies floating in a fluid, one A, which is in equilibrium. Now this body is in equilibrium since the weight of this body is equal to the upthrust R, and they act at the same straight line W. The weight and the upthrust cuts at the same straight line. We have B. This has been displaced through a small angle theta. So in B, the volume of the fluid displaced remains the same, but the shape of this volume changes, therefore changing the center of buoyancy from B to B prime. So if M is the point at which the line of action of upthrust, so the line of action of upthrust is this line here, cuts the original vertical. So the original vertical is this. Then this point is called the metacenter. So my point M is my metacenter, and my point GM is the metacentric height. Finding the equation of the metacentric height relative to the center of buoyancy. So the equation that I'll be deriving will be this. How to get that? So when tilted, there is this strip, these two strips that are formed. So when you look at them from this side, this is what will show. So now I'm going to find the metacentric height by first finding the area of that one strip. So now the area of that one strip will be equal to h times dh times the angle of the tilt. So now the volume of this strip will now be equal to that area times the length. So area times length, the volume. So to get the weight of this strip, it will be density times volume. So the density, this will be rho g v, which is equals to rho g times the volume. So the moment due to this weight is experienced in both the left and the right sides. So the moment of this couple experienced in the left and right sides. So this is the left, this is the right sides. This will be the weight times the distance of both, of the distance to the strips, which is h, the distance to the strips, which is h. So both strips will be h plus h. So I have the moment of the couple as 2 rho g h squared theta L dx. So now this is the moment due to the strip. So what I want to do next is to find the moment due to the change of the center of buoyancy from B to B prime after the tilt. So now the buoyant force FB, which is also equal to the weight of the body, will change from the point B to B prime. So the moment of change from B to B prime will be equal to the buoyant force FB times the distance BM. So this is my distance BM times the angle theta. So my FB will be equal to the buoyant force, which is also equals to the weight of the fluid. Is also equal to the weight of the body. So what I'm going to do is to equate my moment due to the couple and my moment due to the buoyant force. So these two should be equal. So the moment due to the change of the center of buoyancy should be equal to the moment due to the couple. So equating them, I now change my FB to the weight of the body. So W times BM times theta is equals to 2 rho g h squared theta L dx.